Have you ever wondered how rockets defy gravity and hurtle into space? It's a spectacle that leaves many of us in awe, the sheer force, the thunderous rumble, and the blazing trail that lights up the sky. This is the marvel of rocketry, a testament to human ingenuity and our ceaseless quest to reach the stars. Rockets, these mighty machines, have fascinated us since time immemorial. Their origins trace back to ancient civilizations where they were used as weaponry, but today they serve a grander purpose. They are our vessels to the cosmos, our tools for unraveling the mysteries of the universe. But what makes a rocket a rocket? What gives it the power to ascend, to break free from the Earth's gravitational pull and venture into the great unknown? The answer lies in the science of rocket propulsion. Rocket propulsion is a concept that might sound complex, but it's based on a fundamental law of physics. You've probably heard of Sir Isaac Newton and his laws of motion. Well, the operation of a rocket directly applies Newton's third law. For every action, there is an equal and opposite reaction. Rocket propulsion might sound complex, but it's based on a simple principle. Now let's dive into the heart of rocket science, the principle of rocket propulsion. Imagine you're on a skateboard and you throw a heavy ball forward. What happens? Naturally, you'd move backward. This is the essence of rocket propulsion. Succinctly captured by Newton's third law of motion, for every action there's an equal and opposite reaction. Rocket propulsion works on this principle, but instead of a ball it uses gases. The rocket engine's job is to create a forceful action, and the reaction to this action is what propels the rocket. But how does it create this action? It's simple, by burning fuel. When the fuel in the rocket burns, it produces a high volume of hot gases. These gases are expelled out of the rocket at an incredibly high speed. The expulsion of these gases creates a forceful action in one direction. And as per Newton's law, this results in an equal and opposite reaction, which propels the rocket in the opposite direction, upwards into space. The key to rocket propulsion is the engine. A rocket engine is essentially a machine designed to produce and control this action-reaction process. It's a brilliant piece of engineering that harnessed the fundamental laws of physics to take us beyond the confines of our planet. Remember, the rocket engine's job is not just to produce the forceful action, but also to control it. It needs to direct the force in the right direction and at the right time. This control is what allows rockets to launch into space, orbit the Earth, or travel to distant planets. So, there you have it. Rocket propulsion in a nutshell. It's a simple principle, but it has taken us to the moon and beyond, and it's not just about going up. Rocket engines also control the descent of spacecraft, ensuring they land safely back on Earth or on other celestial bodies. Much like a balloon being released and flying around the room, a rocket uses the force of expelled gases to launch into space. The simplicity of the principle belies the complexity of the engineering, but that's what makes rocket science so fascinating. Now, a balloon has air as its fuel, but what does a rocket use? Well, the answer is a little bit more complex. Rockets primarily use three types of fuel: solid, liquid, and hybrid. Each of these fuels brings its own set of advantages and drawbacks to the table. Let's start with solid rocket fuel. It's the oldest type of fuel, dating back to the fireworks of ancient China. Solid fuel is pretty much like what it sounds, a solid composite of fuel and oxidizer mixed together. Its main advantage? It's reliable and powerful. Once ignited, it burns at a steady rate and can't be stopped, which is great for initial thrust. But it's also its main disadvantage. There's no stopping or adjusting the burn once it starts, which means less control. Next, we have liquid rocket fuel, a more modern innovation. This involves two separate liquids, a fuel and an oxidizer, that are combined and ignited to produce thrust. The big advantage here is control, though you can start and stop the burn, adjust the thrust level, and even steer the rocket by changing the direction of the exhaust. But it's also more complex and potentially dangerous, since the fuel and oxidizer are highly reactive and must be stored separately until ignition. Finally, we have hybrid rocket fuel, a combination of solid and liquid fuel. It uses a solid fuel source with a liquid or gaseous oxidizer. The benefit of hybrid fuel is that it offers the reliability of solid fuel with the control of liquid fuel. However, it's not as efficient as either solid or liquid fuel, and it's more complicated to design and build. Now, why does fuel matter so much in space travel? Well, the answer is fuel efficiency. In the vastness of space, every bit of fuel has to be used as efficiently as possible. More efficient fuel means less weight, which means less cost to get the rocket off the ground, and more payload that can be carried into space. So the type of fuel used can greatly impact a rocket's performance and efficiency. A rocket launch isn't just a single continuous process, it's actually made up of several stages. Let's break down these stages to get a better understanding of this magnificent process. The first stage, often referred to as the pre-launch, is all about preparation. The rocket is loaded with fuel, the mission's payload is secured, and systems checks are performed to ensure everything is ready for takeoff. This stage may not involve any literal rocket science, but it's essential to the success of the mission. Next comes ignition. This is the moment we all visualize when we think of a rocket launch. The roaring engines, the billowing smoke, the rockets slowly lifting off the ground. The rocket's engines are ignited, and once all systems are confirmed to be operational, the restraining bolts are released and the rocket begins its journey. The ascent is the third stage. This is when the rocket climbs into the sky and heads towards space. The rocket has to overcome the Earth's gravity and atmospheric pressure, which requires a great deal of energy. This is why rockets are usually built in multiple stages or sections. Each stage has its own engine and fuel supply. As the fuel in each stage is depleted, that stage is jettisoned, making the rocket lighter and more efficient. After the ascent, we reach the orbit insertion stage. This is when the rocket, or more accurately, the payload it carries, is inserted into its intended orbit. Depending on the mission, this could be a low Earth orbit, a geostationary orbit, or even an orbit around another planet or the moon. The final stage is the payload deployment. This is when the mission's payload, which could be a satellite, a spacecraft, or even a rover, is released into space. This is the culmination of all the previous stages, and it's the moment when the mission truly begins. Each stage of a rocket launch is critical to the mission's success, with every component playing its part. Rocket science has come a long way, but where is it headed? We're standing at the forefront of a new era in space exploration, fueled by innovative leaps and bounds in rocket technology. It's like we're on the cusp of a cosmic renaissance. Rocket science, once the domain of superpowers engaged in a space race, is now the playground of private enterprises, their eyes set on the stars. One of the game-changing advancements in recent years has been the development of reusable rockets. Imagine a world where rockets, like airplanes, are not single-use entities, but can be flown, landed, refueled, and flown again. Sounds like science fiction, doesn't it? But it's not. Companies like SpaceX have already made this a reality, drastically reducing the cost of space travel. Along with cost-effectiveness, sustainability is also a key focus. We're looking at greener propulsion methods that will reduce the environmental impact of rocket launches. Innovations like electric propulsion and biofuels are making this a viable prospect. But it's not just about how we're getting there, it's also about where we're going. Deep space exploration is no longer a pipe dream. Probes like Voyager and New Horizons have already given us a glimpse of the outer reaches of our solar system. And with advancements in propulsion and shielding technologies, we're inching closer to sending manned missions beyond the moon to planets like Mars. Speaking of Mars, the prospect of setting foot on the red planet has captured our collective imagination like never before. With missions like NASA's Mars 2020 and SpaceX's Starship, we're laying the groundwork for human habitation on Mars. The dream of becoming an interplanetary species is no longer confined to the pages of science fiction, it's within our grasp. As we continue to explore and innovate, the sky is no longer the limit. It's just the beginning. The future of rocket science promises a universe of possibilities, quite literally. So buckle up, because the journey has only just begun.